Listen, we'll start a new lesson today. It's about networking, computer network. We have what? A lab with connected computers. Our lab is having a network. Whereas we don't go to the internet often. We may go to the internet when we choose to, isn't it? What is a network? It is interconnected system of devices. Hmm? It can be computers, it can be tabs, it can be mobile phones, whatever other things. If they are interconnected through wired connection may be there, or Wi-Fi, or Bluetooth. You may connect them through any means. They are called a network. When a set of devices are connected for sharing information, it's called a network. Okay. The communication infrastructure meant for sharing of data between computers is called computer network. Okay. In the previous tense, only computers could share data, whereas nowadays even our mobile phones have access to data, isn't it? Mobile phones, tablets, laptops, whatever devices we have. Therefore, all of them come under the category of computers because nowadays a computer is defined as a device which has a processor and memory. Processor and memory. Even mobile phones have processor and RAM. They are called computers. The modern era, even mobile phones are classified as computers. Okay. Connection between computers may be through cable, RJ45 cable. We are using RJ45 or Cat6 cable. Our cable is called category 6 cable, Cat6 cable. It has got eight wires, four pairs, four pairs, four pairs of wires. Okay. Through cable Wi-Fi. The full form for Wi-Fi is wireless fidelity. What is the full form for Wi-Fi? Wireless fidelity. Can you repeat? Wireless fidelity. Once more, wireless fidelity. What is fidelity? Fidelity means one person closely following the other without conflict. Without conflict. Two persons may walk. If they are in fidelity, they will walk without any quarrels. Infidels will engage in unproductive quarrels. Okay. Wireless fidelity means two devices communicating with each other without any troubles. It's called Wi-Fi, wireless fidelity. Then what are the devices we normally use for networking? Modem. Modem for modulator, demodulator. The full form for modem is modulator, demodulator. Repeater is a device which boosts the signals, which boosts the signal levels. Repeater. Hub, bridge, switch, firewall, all these take input data and send it to several networks based on requirements. Hub is a smaller level device. Switch is an improvement over hub. Bridge connects two different networks, and firewall separates our network from enemies or attackers. Firewall is a safety computer. A computer providing safety is called a firewall. It discards all unwanted packets of data. Then there is one more thing missing. It's a gateway. Gateway is a large computer connecting two different networks at national levels, at very large levels. Okay. They are called gateways. Gateway is the term we miss here. Gateway. Then each computer connected to a network has got an IP address. What is an IP? First of all, what is the full form for IP? IP for Internet Protocol. IP stands for Internet Protocol. Each computer gets IP address. In the IP address may be in the format IP version 4 or IP version 6. IP version 4 has got a 4-digit number ranging from 0 to 255. 120. Just take a look at this. IP version 4 address is like this: 216.58.201.174. Four sets of numbers separated by dots. Four digits, four decimal numbers. Four decimal numbers separated by dots. They range from 0 to 255. The minimum value is 0, maximum value is 255. Then IP version 6 permits more flexible data, more flexible addressing. It has got capacity to accommodate enormous amount of data, and separation is provided through colon. You just take a look at this. Here in IP version 4, we use dot for separation of digits. Whereas in IP version 6, we use colon for separation. What is the separator in IP6? What is the separator? Colon for separation. Okay. Then how many digits are there? 4 digits. Within each colon, we have 4 digits. And they are not just numbers. You take a look at this. Numbers and letters, alphabets, A to Z. Any number or letter. It means they can use up to 35 different values in one location. A, B, C, D up to Z, 26. 0 to 9, 36 different values can be used at any particular location. Then, how many parts are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 different parts. In IP version 6 address, there are 8 different parts. It's not possible for human mind to memorize all the 8 parts. Therefore, we use a system called DNS, translation of address to meaningful name. Okay. Okay. Now, what are the two systems for addressing in IP? IP version 4 is a common system. IP version 6 is the future system. It's being used, whereas it will be used in the future because it's meant for future growth of the internet. Okay, IP6. Okay. Then how many parts are there in IP version 4 address? 4 parts. Okay. Separated by dot. Separated by dot. IP4 has dot for separation. IP6 has colon for separation. IP4 has 4 digits, 4 different parts. IP6 has double the amount, 8 different parts. 8 different parts. Colon is a separator. And instead of numbers or digits, one can use A to Z also in place of numbers. Therefore, any single place can hold A to Z or 0 to 9. 36 different values can be placed in any particular location. Then each each of the 8 portions have 4 different locations, 4 digits, 4 places. Okay. Done. Domain name is converted into equivalent IP address using DNS. Domain name server. Domain name server. You provide the name gmail.com, google.com, whereas the name is only for our memory. The number, the actual IP address is held in a server called DNS. The DNS will immediately send the equivalent IP address. The computer loads the IP address instead of the address given by us and shows the page as if it were the name we have provided, because it's similar to our mobile phone. Somebody, maybe your mother or father, has a mobile number. I remember or don't remember. I may easily search for the name, then dial the number. I am not dialing the name, I am dialing the number. Whereas I am using only the name for only searching. Similar to that, the name we provide, gmail.com, google.com, all those things are meant for searching. And actual dialing takes place through the IP address, IP version 4 or IP version 6. Okay. Then, okay, IP version 4 has 32 bits. 4. Okay, ma. IP4 addresses have 32 bits of data. 32 bits for storing address. Okay, 32 bits means 4 bytes. 4 bytes, because each byte is 8 bits long. 32 bits means 8 bytes. Sorry, 4 bytes. 4 bytes. Okay. IP. Okay. Internet is controlled by World Wide Web Consortium. World Wide Web Consortium. It's shortly called W3C. W3C stands for, W3 means 3 W. W3C. Okay, W3C stands for World Wide Web Consortium. Can you repeat? World Wide Web Consortium. Once more, World Wide Web Consortium. Okay, we have seen several new terms today. One is IP, Internet Protocol. IP stands for Internet Protocol. Then Wi-Fi, Wireless Fidelity. Wi-Fi for Wireless Fidelity. Then IP version 4, IP4 and IP6 were the two addressing schemes we have seen. IP4 has 4 different parts and 32 bits of storage. IP version 6 has 4 digits and 8 parts separated by colon. Okay, it's a larger storage. Okay, then W3C stands for World Wide Web Consortium. Shall we go further by one slide? I wish to finish all these things here as early as possible. Now, there are 3 types of network. Class A, Class B, Class C. Class A network is a large level network, national level network. We normally call this network a WAN, wide area network, WAN, for wide area network at national levels. At very large levels, we create Class A networks, and the addressing scheme starts with 0 in the first digit. The first digit is 0 for Class A network. The first 8 bits store the network ID, and the remaining 24 bits, because we have 32 bits in total, remaining 24 bits will have host ID. Okay, very large network. Class A is the largest level network, and it can host how many connections? 16,777,214 computers can be connected to a Class A network. Okay, and 126 networks can be established. Then Class B network. Class B network starts with 10. First, if you wish to ascertain whether a given network is Class A or Class B, first look at the first bit of the address. First bit. If the first bit is 0, it is a Class A network. If the first bit is 1, look for the next bit. 0. If the next bit is 0, it's a Class B network. Class B network has got equal share. That is 2 bytes for network ID, 2 bytes for host ID. 2 bytes for host ID. It means individual computers, 16,534 computers can be connected to Class B network, and these computers can further be connected using some other LAN or connection technologies. LAN, WAN, MAN, CAN, all those are different types of networks. We will come to that later. And Class C networks. Class C networks are typical local area networks we host in our lab. Our lab has got a network, and we categorize it as Class C network because we have 8 digits, 8 bytes, 3 bytes for network ID. First 3 bytes go for network ID, and the network ID starts with the first bit 1, second bit also 1, third bit is 0. Therefore, if you find the 0 at the first bit itself, it's Class B. If you find the 0 at the second bit, it's Class B. If you find the 0 at the third bit, it's Class C. The address can be easily found out. And okay, host ID is only 8 bits. It means 254 computers can be connected to a LAN in a local area network like our computer network. How many computers are permitted? Only 254 computers at the best, at the maximum. You cannot go beyond that number. Okay. Then what are the classes of network? Class A, Class B, Class C. Class A, Class B, Class C. Largest type of network is called Class A network, and the first bit is 0. The next larger network is called the Class B network. The first bit is 1, second bit is 0. And the next larger level network is Class C network, and the first bit is 1, second bit is 1, third bit is 0. Okay. Then very low number of computers can be connected to class C network, 254. You cannot go beyond 254 computers in a class C network. With this, we come to the end of today's session. Maybe we will have one session in the afternoon. With this, we close. I wish to complete computer networks as early as possible because we are lagging in terms of theory.